Hi everyone, I'm Michael. This thing should appear in a bit. I'm a software engineer. I write C++ by profession. If anyone has any Haskell jobs, I'd gladly jump ship to your company. Let me know. But today we're going to talk about the pain of programming things in Java and how, at least me and a couple of people have worked to remedy that, programming in Frege, which is the dialect of Haskell. So this talk is going to follow pretty much that linear structure. I'm going to focus more heavily on the code example since it's more of a practical hands-on thing. So while we're at it, if you have your computer out and you do have Android Studio, you can open it for now. If you don't, download it before we get to the code examples, because we'll do some live coding together towards the end. And I'll show you a couple of demo applications at the end to give you a sense of how much coverage the API has and the sorts of things. Welcome. We haven't really said much, so. And to show you the kinds of things that are possible to make, because there's always the issue of constraints, how much you can reasonably make with a programming language integrating into another system. I know this constraints existed for Ada. We'll talk about that later. It's not time to badmouth the opposition just yet, but we'll talk about the motivation for using this, the language itself. That's always a question people have coming from Haskell. Setting it up, a couple of quirks about the programming model, and we'll get into making things production ready, which is just a single slide, to be honest, and then a couple of demos preceded by a live code. So the motivation for writing applications in Frege, or in Froid at least, I think for now are defined by these three goals. To have practical, everyday functional programming, because a lot of how I learn when I'm writing a programming language or I'm learning a programming language is you make something, you use it, you discover quirks and bugs in it, you reiterate, and then your creation starts to take life. And that's kind of hard when you're confined to a desktop, considering people mostly use mobile devices. So this gives you a space in which to practice and use those skills in a different platform in a way that can be sort of didactic and in a way that you can learn. And the second is sort of similar, the GUI problem in Haskell. Try setting up GTK-HS or Qt-HS. It's a nightmare. This is a very quick and ready-to-go solution to that, where you can do a lot of your programming logic in Haskell, and then you can integrate with the Android system pretty easily. And it's also a solution in the Android space. I know there's a couple of applications and languages that are touching on this now. Ada has a solution where I think you compile your application into a jar, put the jar in as a dependency to your Gradle file, and then call the method that you intend to call from your Java code through some kind of glue, which I think for now is pretty hacky and it's not a very elegant solution. So this is another solution in the solution space. I know Clojure and Scala have a couple of libraries, but again, you have bloated jars and not really FP. I don't like parentheses, so I don't use Clojure. I'm sorry to any Clojure developers here. And then Scala is just Java, basically. I stumbled upon Frege a couple of months ago. The developers were pretty nice about it. They helped me with a lot of the formalisms around this, how it's different from Haskell, making a lot of the library. And it's a pretty small, intact, conducive community to contribute into. So look into it on GitHub and on Gitter. But basically, this is supposed to provide an alternative to mostly that. So on the bottom left there, you have defining just a simple thread in Java, async tasks, where you define what to do before, during, and after a download. And here you're dealing with a whole bunch of like what they call functional semantics in Java. With, I think that's the top right, actually. Yeah, where you have to set some factories and have some new instances and all that stuff. You don't quite get the same sort of FP appeal even in Java 8 and Java 9 with the functional interfaces and the lambdas. And even if you do, it becomes very verbose, and it usually just manifests itself as like higher order functions and none of the abstractions. So that's a solution to that. And the perennial null problem, which languages like Kotlin are starting to address with optional nulls. Not quite as elegant solutions in Java with the annotations and all the rest of it. So this is mostly to motivate cleaner programs, cleaner Android programs, a lot more efficient, easier to refactor, easier to test. I don't need to sell you on any of the benefits of using Haskell to write applications. Most of those port over, and this library does that just perfectly. So let's take some time to talk about what Frege exactly is, because that's a question I get a lot from Haskell people. Frege is a dialect of Haskell for the JVM. It differs from Ada in that Ada is more so for people wanting to use GHC proper, on the JVM, so to compile any arbitrary Haskell package. But Frege comes from the other angle. It says, I'll work with any arbitrary Java package with very little overhead. So that means it's a better candidate for integrating with current Java ecosystem things, like reactive bindings or any libraries that are already built like Butterknife. So if you want to get productive and not so much formal, this is probably the best library to help you do that. But if you're a person that just wants to play around with different applicative instances in Android, then you probably are better off going with Ada. Actually not, because it's still possible in Frege. So let's talk about how it's different from Haskell. So Frege, just starting from where it's common, is a purely functional, non-strict, strongly typed static language in the spirit of Haskell 2010. So it strives for Haskell 2010 syntactic compatibility and easy Java interop. So I put a note there that Frege is a Haskell for the JVM, not a GHC. As such, the project's goal is not to allow any arbitrary GHC package to compile, but rather to bring Java people or to bring FP into the Java world. That being said, some GHC packages can be supported if you do very minor sort of tweaks on the package itself. If you download the source and try and recompile it yourself and package it into a jar, it's definitely possible. And there's, I think, moves to make it a lot more stricter, compatible with any arbitrary Haskell package, but that isn't like an immediate goal. So now that we have that out of the way, syntax looks pretty much the same. A couple of other perks. So that's just a function that applies the cycle of an identity and multiplying by 2 to the infinite list made by the cycle and some arbitrary list that you put in. So that compiles on both Frege and Haskell pretty easily. And then that's a data definition for a tree. I put that there to show the quirk, which is that you don't say the deriving instances are put on separate lines. So you say tree A is whatever it is, and then on a separate line you put derive show and in parentheses the whole data type, rather than in Haskell deriving show eq and all that stuff, because it compiles through interfaces. And I think semantically, it probably was easier for Ingo to make it compile, or to put a derive instance, to put type class instances as separate lines rather than inlining the definitions. You also do get record synonyms straight out of the box, so that shouldn't be a problem if you're working with JSON libraries, which you're probably going to end up doing a lot in Android. If you're working with JSON libraries that require you to have similar names for things. And the other thing is main can be either an IO action straight, or it can be an action that takes in a list of strings and then goes to the IO action. What does Frege compile to? Frege compiles to Java and then uses Java C to compile down to bytecode. That makes it easier for Java C to do optimizations. We're not like redoing a lot of the work of the compiler. All we're doing is transpiling it down to Java, meaning it's easy to interop with a lot of Java libraries. It's not tremendously readable, but there are compiler flags you can put in to make it a little more readable. But these three examples, or these three simple examples, should look kind of understandable and intuitive. So we have three functions. One, which is an add function that takes in an x and a y, polymorphic num class, and then adds them together. It infers the types. The second one, add one, which takes in two ints. And the third one, add two, which takes in two arbitrary length integers, which I think in this case is 64-bit integers, and then gives you another one. So the first thing compiles to an add function, which takes in a number context and then the two arguments, does some type resolution in the context, and then adds them, or applies the generic add argument at compiler level. The second one, unsurprisingly, compiles to a function add1 that takes in two integers and then adds them with the normal add operator, and then the arbitrary length integer compiles to a big int. So at some level, the functions are very readable, except if you are working in a monad, like the IO monad, you get a lot of nesting, making it incrementally harder to read with a lot of the types. But again, there are compiler flags you can put in to make it a lot more readable. The differences that I think kind of matter between Frege and Haskell, well, that you might end up running into, besides the syntax, that data types and namespaces, so records can be overloaded. You can have similar names. You have rank and polymorphism supported outside the box. That being said, it doesn't support language extensions, but there are some language extensions that are supported. They're listed on the GitHub repo. And you get regular expression literals, so if foo regex a, it'll pattern match to whatever strings start with a, going through the function, and then everything else doesn't start with a. And there's a REPL to do any random Frege coding online. So in this case, it's an example using JSON. You have a weather class, which is a location, temperature, and string, does some parsing and then displays it. Ooh. Evaluate main, and it just calls main, and main renders that to JSON, which is what the function does. So it's actually a pretty robust language, and I would say it's ready for most types of applications, in fact all types of applications, without qualification. Now let's go to the interesting part of the talk, how to set it up for Android. Setting it up for Android, currently how it works, I haven't written a separate plugin for it at Gradle level. How it currently works is you write a Frege file in a Frege source folder, it compiles it to Java, replaces the Java files, and then uses the normal compile workflow to compile it from the Java file into Dex or Jack or whatever the backend is that Android Studio is working with. So then, because everything happens at Gradle level, recompiling the Frege is a matter of resyncing the Gradle and then just running the application pretty normally. So again, we'll take some time to kind of digress and go to the wiki to just show up a section of what it looks like. So this is the script that you attach at the bottom of your Gradle. It just collects everything in your class paths or your different class paths, resolves your dependencies, and then runs the Frege compiler at the bottom and does some exception handling here and printing error messages. Nothing too hard. And then every time you run the Gradle sync, it recompiles the whole thing. So a goal of mine working with Froid is to make it very syntactically similar to what Java would look like on Android, so that we can curb the learning, we can kind of override the learning curve of learning a whole new DSL. Because the problem with DSLs is that once you have a couple of use cases up in tutorials, people understand them, but every time someone wants to use for something a lot more robust and wants to use the existing ecosystem, it becomes very difficult to see how those kinds of things port, and I have to keep on answering questions on Stack Overflow, and I have a job, so I can't be answering questions on Stack Overflow every single time just to make people use my library. So it looks very similar to just vanilla Java. And the motivation for this is that a lot of stuff that you're doing at Java level, at least, is UIs with fragments, with view pages, and all the rest of it. And then a lot of the logic can go into Frege land or Haskell land. So on the left, you have a simple activity. My activity extends the activity class, which you imported at the top. You call the super method or the super's onCreate method, and then you set the activity view to the resource ID. Oh, wait, just a show of hands, how many people have worked in Android before? Because I don't want to have to re-explain a lot of things or like assume knowledge. Okay, but this is a pretty simple activity if you've seen Android. And then on the right, we have Frege, where you import. The imports look similar, so instead of Android dot whatever it is, it's Froid dot whatever it is. Activity and bundle. And then we have that little line, native module type activity, which is a section that says this whole module, this whole class file is going to extend activity. That's what it does, and that little curly brace thing is for any code that's hoisted to the top. So you can inline some Java code in Frege by doing that, by saying native module or native type or whatever it is, depending on if it's an interface or an activity or just an inline. And then that little curly brace defines the sort of the Java code that's going to go, that's going to be inlined into a Frege code in case you want to interop with something, or you can't find a way to make something completely pure and you need some mutation. You can define some Java variables there, so you don't hit a brick wall at any point. And then the next section, pure native R activity main, defines the resource. Pure just means it's a pure function. It's an integer whose value doesn't change. And the native means it's a native definition. Then the type name and the whole type, the whole qualified type name at the bottom in quotation marks, and then you specify that as an integer. Now you have access to that. I'll probably work on making that look a little nicer, but for now that's how you define resources. And I tend to like to put them in a separate file called utilities, so all the class definitions for the activities that you open and the resources and any kind of bindings you have to work with another Java application. And then on create, the super is called for you. So anything that calls super dot whatever it is, I took the liberty of calling at library level. So the library's on create is calls the super method. So all you have to do is set the content view. So it looks pretty similar overall, and that's the goal, to allow most of the logic to happen in Frege, but most of the UI to happen in in what looks like Java. This whole section is how we integrate with Android and Java, how we model things like inheritance, and how we work with different subclasses of different things, because Android is essentially an OO library. You're kind of working against the machine a lot if you try and make everything like run away from OO. So I found a way to sort of embrace the object-oriented programming, and at some stage like model some kind of multiple inheritance, which is a good thing. How we take objects. So in Froid, objects are just records of functions. In fact, that's what objects are, right? When you have a class and functions attached to it and some state attached to it, what you really are trying to do in like not OO is have an object or a record with closures and then some functions on those closures. So that's how we treat them in Froid. And we call them delegators. So each class that has that can be subclassed, or each class has an implementation that you want to override, we call has an attached delegator. So if, for example, you wanted to override a GL surface view to work with OpenGL, you have the GL surface view class, and then you have, in lowercase, GL surface view dot delegator as a separate import to define the record of functions that goes with the GL surface view. So, pretty hacky example, but then it gives you the gist of it. We'll get to a more involved one during the code example. But let's say you have some arbitrary class B, which has a method where it takes in an int and then gives you back an int. And let's say you wanted to extend B and then override the method in a class called A. That's how you do it in Java, nothing surprising. But how we do it in Frege and Froid is you have a delegator class which has a method maybe int to int, and then you have a default delegator which has nothing in it. So you can have like no implementation on a function in case you don't want to override everything. And then the different classes, or what corresponds to different classes in Java, just become like different functions in Frege. So then B becomes like default method overrided with some computation, just x plus, just the lambda that goes from x to x plus n. And then A doesn't need to override B or know about B. All it just needs to know about is the delegator, and that it needs a method, which is just some computation from int to int. And then how does this scale? This is an example. Of course, this part of the example is a little more dumbed down. But let's say you have some view pager that you wanted. This is from a book, the Big Nerd Ranch Android book. Let's say you wanted to override the fragment state adapter, and you wanted to override the two methods, which are getCount and getItem. You do that with an anonymous class in Java, and you'd set the adapter for that. In Frege, of course, this section of the application is like a few more chapters ahead, but you'd make a delegator, which is a fragment state pager delegator, override the default with the two methods you defined, getItem and getCount, shift the logic over there, and then call the make method, which just assigns all the different functions to the different function calls under the hood. So it reads pretty similarly to the Java, and then you can do stuff like front load it with IORefs or mvars to maintain any kind of state that you need between functions. So you're not like capped into using just the local functions in the records. FFI is pretty simple. I think it's the simplest I've seen from the JVM languages, or the ones that interop with JVM, except for like Kotlin or something that's like strictly imperative or should read almost like Java. But let's say you had some class called API, and a couple of examples here. Let's say you had some class that did some computation on the instance API. So again, method which takes in an I and then gives you another I, does some computation along those lines. And then you had another method which was static, which did something similar to the previous method. And then you had some method that didn't do anything, was an IO action, was void, did some mutation. And then you had a nullable class which returned like a string that could be nullable without any type annotations. So what you do is you define data API, like a data type, and then you say its fully qualified name as a native definition, native example.hugs.api, where the first instance, it's not a pure method, is it? Well, it doesn't do any mutation, so you can label it pure. So it's a pure method that takes in the API object, so you can call it on the API object. It takes in an int and gives you another int, and that's all you need to define. So anything that, whatever the implementation runs on the Java level of method, now is available to Frege. And that's a nice way to make your applications a little more like type safe, because you have to front load or upfront annotate the types for the application. And then the second one is a static function. So static functions, because they aren't called on an instance of the object, have to have the fully qualified name either in quotation marks. I think they're kind of optional, but I like to put them. So that it's another pure function, and its native definition is that whole fully qualified name, and then it's a function that goes from int to int. And then the function that does mutation obviously doesn't have a pure annotation. It's just native mutation from the API object to int to IO. Actually, it should be mutable IO API. I should fix that. So anything that's, if the data definition doesn't say at the top that it's mutable, then any instance that's called inside it that returns an IO action should be labeled mutable IO, which is the type synonym for something, something, something with real world and something else. But if you want to call just API and you know that this class is inherently mutable, which is the case for most classes in Android, you're going to have to put the mutable somewhere at the top before the native definition. We'll get to that. And then let's say you wanted to inline some arbitrary Java code to like extend the class like we did previously. So you have a module main where shouldn't have parentheses there, but you wanted to extend some class other, and then there's some Java code that you wanted to inline, and then you had some function test that had some part of your logic. This compiles to a final public class main that extends other, and then the hoisted Java code goes to the top. After a lot of type annotations and whatever it is that goes at the top of a Frege program, we'll look at one in a bit. And then the test function compiles to a static function. All functions compile to static functions. As a result, we have to do some reflection at library level to interop with Java, but then it's pretty type safe, and it's pretty easy on the heap and the GC. And because everything is static, even the methods where you would call like some object dot some function are essentially static calls on the object. So for number conversions, that's how you do either types in Frege. For the first func, so it's a number format exception or an integer, and on the integer 3 you call .int. What that desugars to is string.int on the call of 3. So everything's maintained as a static function. So nothing like crazy is happening under the hood. So even the dot operator just compiles to a couple of static functions. And then you can have the fluid API as well. If you call bind on some kind of object which is wrapped in some kind of monad, usually the IO monad or the IO actions, it's make object, the bind operator, and then the underscore, like in Scala, kind of just says whatever object was returned from the previous function. Keep using that. So the jars can get pretty large because of the constant overhead of having a whole entire compiler or like all the types inside. But then once you do stuff like ProGod, it goes, so a vanilla Java hello world type application should be about 800 kilobytes, and a vanilla Frege application or Froid application that does the same thing should be around about like a megabyte or a megabyte point something. So it's not a very big difference, considering Scala jars can get up to 5, and I imagine Ada jars can get up to like, I don't know, like 5, 6 to 8 as well. And when programming for mobile platforms or mobile first, space matters because it determines the amount of battery your thing is consuming or whatever it is. And the caching can also have an effect on the speed of the application at scale. So space isn't a problem. It's just vanilla Java code with some of the Frege compiler or some parts of the Frege type system and the run types in the code. And I would err on using strict types, because if you go back to, let's see, where's the example with the add? Right, if you go back and look at the add function, the first one where it infers the types. So to model lazy evaluation, we have a generic thunk class which has a call method which can nest itself to simulate laziness. Everything is compiled into thunks, meaning that you have to make a new object on the heap every time you want to evaluate something lazily or have a lazy argument. That can, for something like OpenGL bindings, that could be quite a big overhead. So on very resource-intensive applications, I would say, are on the side of using strict types. But for everything else where you're just manipulating a view, it should be fine. Oh, that's not running like on a constant feedback loop. And the garbage collection is easier because with static functions, you're not maintaining a lot of heap state. And most of the state that you're maintaining is like local to functions. And as soon as the function leaves, you're kind of fine. And because of static methods, it's just easier to deal with. And Android, and I think Android, at least Google, says you should prefer static functions for most heavy computations that don't use a lot of your instance variables, for example. So garbage collection tends to be like kind of easier. And then on the wiki, on the GitHub repo, there is a default ProGuard script that minifies the jars and all that stuff. So we'll live code a very simple hello world together. So if you have your laptops out or anything, this is the time for it. And we'll go through some of the quirks of making a new project. So we'll call this Lambda example. Phones and tablets support Android 3. Everyone's seen Android Studio, so I'll kind of rush through all the setup looking stuff. We'll add no activity. And then Android Studio should get us up and going in the next few years. But oh, thank you. That's so nice. Well,
maybe not that dark.
all right. So we have an empty application. We want to integrate Frege into it. First thing we do, we go into project mode because that's how we get access to every single one of the files and stuff. First thing we need to do is we need to package Froid and put it into our libs and the Frege compiler as well. So we copy this over. Nope, don't cut, copy. You could add it as a dependency once it's on Maven and stuff, but the problem with that is that I think parts of the compiler use Java 8, and I don't think Android Studio has support for Java 8 like straight out the box, so I kind of tweak them and put them in lib. But hopefully with 2.4, well, the later versions of 2.3, there should be like Java 8 support straight out the box. But for now, you add the dependency to that. And then we add the dependency to Frege. And then we go to the applications build.gradle, and then we go back to the initial Gradle script that I showed you from before, wholesale copy pasted. This will be a plugin at some point, but for now, put it at the bottom of your build.gradle. And if you're using 2.2, the build cache directory is in a different place, which is what that little annotation at the top is. So if you're coding along and you're using 2.2, comment the build directory out and use the other one instead. Now once that's set up, we can try and sync the Gradle to check if everything went accordingly. Right, everything seems to be fine at Gradle level. Now we have to do some stuff because it's a pretty involved compilation job. We have to enable like multi-dexing and make the heap significantly, not significantly, but like slightly larger to accommodate the Frege compiler. So we increase the heap size. Everything's on the tutorial, by the way. So we go back, increase the heap size, enable multi-dex, and just to make everything look nice, that's if you have the Haskell plugin for IntelliJ. It should do some syntax highlighting for Frege as well. And then finally, you go to your Gradle properties. Yes, we want parallel builds. And let's have a heap on steroids. It's worth it in the end. Right. Resync the Gradle. Everything should be fine. That's as much setup as you're going to need to do, which is, I'm going to provide a library level thing for, you can download like for Kotlin and stuff. But who knows what happens with the Gradle build system and how fast it's moving. So now we can make a new activity. Let's go here. Project not ready. All right, the Gradle syncing. Actually, while it's syncing, in our source directory, now we support both Java and Frege, so we go ahead and make a Frege directory here. And it's highlighted blue because it recognizes Frege as a source directory. Right, this exists now, it's fine. And then we define a new activity, basic activity. Let's make it the launcher activity, and then we finish. What just happened? It was just spazzing out. All right, so now in our Java directory, we have a very basic activity, overrides app compat activity, does some floating action bar stuff. I don't think I like that. So now we go to our Frege file, and then we make a new Java or a new file, and we'll call it main activity.fr. We maintain the same package name, so go ahead and copy that over, and that'll be the module namespace. And then finally we call it main activity, where then we do our imports. An optional bundle may or may not be null on an IO action. We take in a self-reference to the object, the bundle, and then in our do notation, we set the content view to whatever the resource is. That has the resource file. We'll look that up in the XML in a little bit. r.i.layout. And then over in the XML, or rather over in the Java, we know it's activity-main. And that's an integer. Right. Unless I missed anything. That should be enough to get like a simple hello world application going. So we resync our Gradle to check if it compiles. And it's not too surprising, it should compile. This module derives from. I forgot type. So what this will do is it'll just compile it to the same namespace as where you have your main activity.java, and then that file will probably be like completely gone after that. And then this will be your new main activity. Right? Everything parsed. Your Gradle's resyncing. Go back to the top. Everything's compiled. We open an instance of the Android emulator just to check. And in the meantime, oh, the device isn't registered yet. And in the meantime, we run the application. And the good thing is that now let's look at what it compiles to, actually. So you have Unicode literals in Frege, but only when they appear as like individual characters, so you can't like bar arrow for some sort of annotation that you have written in your code, or some type that you have in your code. But most of this is Frege compiler setup. And you have some annotations that say whether something was imported, or if it's in space, if it's in scope. And there's some like privacy semantics as well associated with the language, so you can still use abstract, protected, or private on the constructor, on the data type as a whole. So that whole sim linking stuff at the top says that type of stuff. We get some sim linking, and then you have the final compilation, final public class main activity extends some implementation of the Frege activity that can run the lambdas that you give it. So it's a custom Froid activity. And then you have a final static class which returns a unary function that gives you a real world short, which is an IO action. That's how they encode shorts, or that's how they encode actions in Frege. And then onCreate takes in a native activity as its first, and then a lazy bundle as a second, and just runs the activities set content view and does some stuff to like resolve it outside over in the compiler. So this is running. The first run's always going to take a pretty significant amount of time, but nothing more than like 4 or 5 minutes. Maybe around 3, because it has to do a lot of the dexing. And after that, everything is cached. Because you're using Java 7, you still get access to instant run. So there's no overhead of like using any other language and Java 8 semantics and having to enable Jack and like recompile. But yep, the first transform classes with dex for debug is pretty involved. While that's happening, let's look at other applications developed, or locally at least, that I've developed in Frege. So if you've used the Big Nerd Ranch book, this is what criminal intent looks like. We can still maintain a lot of the same state. I don't think I'd put it to like do that. Oh, I did. Look at me. Right, so you can select and unselect. It maintains a lot of state through a lot of mvars. We'll go through the code after that. And it uses view pages. I think I put it to work with, the normal view pages through some sort of subclassing semantics. So the API is pretty robust and can do that. Oh, our application's running. It's an empty application because we didn't put anything on it. But here it is, a simple hello world. It compiled in apparently 2 minutes, 6 seconds, but I'm skeptical. But that was a nice 2-minute compile, and every other recompile is going to be like under 30 seconds because everything from there on is cached. Headed back to criminal intent, which is part of the demo applications. I hadn't finished it, but most of the view subclassing works. And just for the cool effect for conferences and presentations, worked with the OpenGL API, so you can get a movable cube. People like shiny things, especially when you can press on them. Because it's Haskell, like you rarely see anything that's shiny. You always see like, oh, and this is how this brings up to an applicative. It's like, yeah, I made a cube spin. And the code for this will go through afterwards. And the first big Nerd Rant application, GeoQuiz, which I ended up finishing. So the questions work well with looping. You can answer them, you can cheat on the questions, show the answer, go back. And then after that, the buttons aren't available to you because you cheated. So a lot of maintaining, it was a proof of concept of maintaining states between activities, which was at first a problem, but we managed to get. And a small victory that I'm very proud of, you can flip the screen and maintain state. Let's hear for that. Thanks. But yeah, because working with that and maintaining a lot of the sort of OO-ish state of Android ends up becoming difficult, but there's been hacks around it, and it doesn't compromise a lot of the stylistic choices I've made in making the library, and a lot of the UI choices. So like in principle, absolutely any Java or Android package should be compilable and writable. And Froid, as it stands right now, with a little more bindings for a couple of things that I missed API-wise, but on the whole, it's fully robust. So our hello, or is it, what was this thing called? Oh, Lambda example. Lord knows where it is, but it's somewhere there in my recents. Oh, it's just called main activity. That's nice. Right, so that works pretty well. And then you can do some stuff with inlining the resources, defining maybe some arbitrary text view. Let's match the parent and let's wrap the content. And then let's give it an ID. Can't remember what the semantics for this is. Is it plus ID? There we go. And then once we have that, we can go ahead, go here, almost copy paste this definition. Oh, and the R is for resource, and then C is for classes. ID txt view, I think I called it. Yep. And then we go here, import text view. It's a widget. We convert it over from a view, and this takes in a function that converts an integer to a view, find view by ID. And finally, the resource to call it on, and I think in our case, it's r/textView. All right, let's test my claim. I think it's dubious that it will compile pretty quickly now, but it has to run the Frege compiler, then inject it, and then run like the normal Android compile. But then generally you're looking at pretty tight compile times compared to most other packages. Right, compiled. Since we have instant run, well, now it's going to compile the Frege again. No dexing, package, how many? 23 seconds. Apparently it was slightly longer, but we'll go with the compiler's word. And then it springs up after it installs the APK. This is not a lag caused by my library, it's Android. Although they are working on build speeds. There we go, and then everything, the text view is there, it says hello world or hello Frege, whatever it is. So a little more involved app. Let's look at a little more involved code example. So let's go back and look at how you would write applications that are a little more involved. So we're going to look at the code for this application, the GeoQuiz application, the one where you answer questions. Look, it still knows you cheated on the question, even though you went out of the application. So we're going to look at the Frege for that. Here's our main activity. So we have a couple of imports. Is this clear? Or should I make it a little bigger? Make it a little bigger. We have a couple of imports. And then you define native module type activity. And here's your onCreate. So I like to package my UIs into records so you don't have to pass around a lot of state. So it's just C-type struct. And this is what the UI is, some context object, because you're going to need to refer to the context a lot, the text views and the buttons for true, false, and cheat. So then setup UI just does that. It calls everything from the view and then returns the record that contains all the views. And then finally, you decide the first question based on the instance of the bundle. So it's either the actual first question in the list of questions you have, or it's the question that was most recently stored in the bundle in case you flip the screen to maintain state across activity switches. Set the text, see which ones they cheated on, return the state from the safe instance state as well, store it over as a list of questions, see if to hide the buttons, and then to maintain the ones that you cheated on, we create an mvar. Would work pretty well with an IORef as well, because we're not doing a lot of concurrent stuff. And then the buttons, we set the on-click listeners. The good thing is that for a lot of applications where you have a lot of buttons and a couple of functions that you're using, you don't have to do this, like the whole on-click this, on-click that. You can just zip. Haskell semantics coming in handy. So for the navigation, we just zip the on-click method, again with the underscore. On-click from the buttons folder, and we define the buttons by just mapping over a list of resources and then zipping those list of resources or the map buttons over some functions that we defined, some partially applied functions. And that beats having to write anonymous classes for every instance of onCreate, or even in the case where you just have to write lambdas. That's a pretty efficient way of working, or including functional semantics into the Haskell programming, into Android programming. And then the question types, you could use the UI to maintain state for a lot of applications, so this is a proof of concept of that. So your question model is just text and the answer, and then your questions are stored in a normal list. And what you do is you just have the questions sequenced in a tuple where the first element is, or the first part of the tuple is the question that you're currently on, and the next part is the question that you're going to, and you do a lookup every time. That way you don't have to maintain like state and mvars. So there's ways to like kind of run away from having to have a lot of state between different classes or different functions, and that's one of them. And then calling another activity as well, or defining things like on activity result, looks pretty much like the normal Android code. And then a demo of the OpenGL bindings. Again, I used OpenGL 1. I didn't use OpenGL 2 because you had to define shaders and all that stuff, and that was a little too involved for a proof of concept. But it works very well with again, this top part looks the same, a couple of imports, work with the data.bits, define a surface view. So this is where the subclassing thing happens. So your new surface view, your touch surface view, isn't a separate class, it's just a function, and that function is called by the delegators, or you call a delegator for the function on the object. So we define some IORFs that are going to be used by all three methods that it overrides. So this, in this case, the angles and the previous x and y coordinates and maybe the renderer. And then we make the surface view from the delegator. We make the delegator first, which is the separate function, and the context. And what the delegator then is it says on touch event, again, I made my thing strict so that it doesn't have a lot of lag for OpenGL. And then we define the lambdas for the touch event and for the trackball event. And if you didn't have a trackball event, you could just put it as nothing, or you wouldn't have to override it in that case. And then here are your functions that just modify the IORFs, get it, and then update the angles. So once all that's done, of course, only this part is the logic that does the flipping, the touch scale factor times the dx and the dy. But you can imagine an application with a lot more involved logic that you separate out into the Haskell part and the float stuff. And the same logic for the cube renderer, you just make the surface, you make the delegator by, we don't need any lambdas here, we just define the functions. And then some GL stuff. and then call the Lambda. And then the GL part of the code is just maintaining a couple of vertex buffers, color buffers, and index buffers. And then all our types are just encoded in this normal strings and all the rest of it. Right, so that has it for the examples. Future work. We've already been through all these examples. Future work, I think I want to do a lot more proof of concept applications, a lot more memory profiling, because it does get a little memory heavy for involved applications if you're making thunks, I said. But I think there's a couple of ways to circumvent that sort of thing. And something that I'm looking to do in the not so near future is to integrate with the reactive banana and have like strict FRP, like native FRP, with Froid being used, as well as integrate with a couple of other pretty useful Haskell libraries and a couple of pretty useful Java libraries, at least the ones that a lot of developers use in both sides of the world, so that you can have a pretty unified ecosystem in that respect, and some more stuff with the API coverage and all the rest of it. So I think we'll get into 5 minutes of just questions. Thank you. Oh, wow. Sure. Joe?
Are there any points where you have any really crazy type signatures?
In it?
Or something just really long, kind of. It looked really nice in the presentation. You just had three things. But are there any points in an application where you might have something really, really long, specific to Android?
What do you mean? Like in the Frege code or in the compiled Java code?
In the Frege code.
Where I have them right now, or can you in principle have them?
Is that something you would have to do at any point?
Oh, right, in case you were like passing around a lot of things.
Yeah.
Usually just throw them around in records if they move around a lot together. But yeah, type signatures can get pretty involved. I think for criminal intent, one of them was pretty involved. And they do tend to kind of crawl out of the screen. Can't remember which one it was, but I think it was the fragment. Yeah, where you can have multi-line things where you have to vertically inline them, but it can get kind of involved. But there's ways around that. But in this case, you can't avoid it, because first you need self-reference. Second, these are all the things that onCreateView needs to run. So the layout inflator, the view, and the bundle, and then returns the view. Oh yeah, so I've changed the API so that now you don't need to have mutable I/O. So I've made every type like mutable out of the box. So that this, again, I think should look shorter after some time, but you can get pretty involved type signatures.
Is it at all on the Frege roadmap to support cross-platform stuff on iOS?
No, because I think GHC does support some iOS development, so that there wasn't a very big push for that. That being said, since you can do it, oh, is that me or is that the microphone?
It's the microphone on the
That's the podium mic, yeah.
Goodbye. Yeah, because you can get JNI for a lot of the stuff that you need, like x86, like ARM compatibility. I don't think it's as immediate a concern. And even if you do, you're not like integrating into the iOS like native's UI system. You're more like doing OpenGLE stuff. But I could look into it, but I'm not an iOS person. Like all my devices are Android. I work at Google. Like I'm so far from iOS. But if there is a need, I think it's easy to port over the semantics. Like once you have the front end, it's just tweaking over a couple of the native definitions and plugging into iOS and the storyboard system, whatever it is iOS developers use. Joe again.
So you showed Java code in your Frege, but can you call Frege functions in your Java?
Yeah, there's a couple of proof of concepts of that online. But since it compiles to just static methods, you just say, so for example, for this application where I have this whole long type name and criminal list.activity, if I wanted to refer to new crime, whatever, it would just be like crime list fragment dot, the method it's trying to call, because it's just static methods. Of course, if you're trying to call like a partially applied function or something of that nature, and you're trying to do a lot of the stuff that the Frege compiler is doing in Java, that gets a bit hairy. But for the most part, you could do where you write a bunch of code in Frege. It's a static function, then you call it from whatever Java you have. So the interop is pretty good if you just want to have some part of the logic in Java. And an interesting idea that I got from someone over at the South Bay Haskell users group was to use JNI to integrate with the rest of the Haskell ecosystem. So you can do a lot of the network I/O stuff in Haskell, or like use any arbitrary GAC package that does a lot of stuff natively. Make some JNI layer to call it, and then like have the UI code in Frege as a way of kind of coexisting with existing Haskell libraries. Yeah.
Are you using this stuff professionally, or is this something you're doing on the side?
A mixture of both. So there's an application, or at least there's an application on the App Store that uses. I'm trying to get push for it. Somewhat at work, but legacy code, and so there's a version of this REPL on Android. Try Frege Android, and it's basically the same thing, and it's written in Frege too. So this is an example of something quote unquote in production that runs in Frege. So this. And then some REPL here where you can define some functions.
Emulator, is that related to you bringing it up in the web browser?
Sorry?
How did it come up in an emulator?
Oh, because
Yeah,
yeah, right, because I built it.
about bringing it up in the web base somehow.
Oh no, but I think you can do that with instant apps, like maybe. Yeah, you can define some modules here and compile them, and then run them on the console. So this is kind of a fully fledged application, example application. I've only gotten like a couple of bug requests in, but for the most part, it's been like pretty stable and pretty well used. A lot of it right now is trying to automate the build process, so we're not using Gradle scripts like make a Frege plugin and find a way to inject it over. But I think, in principle, it is usable in production. I'm just looking for a use case first. Probably make some like Reddit client for some subreddit in it, and then have people like the Haskell Reddit, and then have people maintain it from there. Okay, that's round about all the time I have. I think this is the break now. Yep, but thank you.